we intend to do today is to give you an overview of derived credentials. But before we do that, let me just say that Benoit and myself are from Gemalto, which is a multinational digital security company with offices pretty much all over the world. Both Benoit and myself, we are based here in Austria, as Scott mentioned. And we are working with a group which is on research and innovation and looking at identity and security space. So what we'll be talking about today is in line with what our core group does. And it's about derived credentials and how we can use that to give a better experience to the users for the secure applications which they have on their mobile. Now you might say that, well, these are two different things. I mean, usability and security. And when you talk about that, I mean, the term usable security sometimes is referred to as an oxymoron. That, well, you can have usability, but then generally you will not get security. And if you have a secure system, most often it is not usable. So how is that possible? And part of the talk is to essentially lead you towards that exercise where we can show that, well, it doesn't have to be an oxymoron. You can have both, and there are ways that we have been looking at. So to lay the context, let's talk about PIV. So PIV is, which is personal identity verification. It's a standard which is pushed by the US federal government. And what it does is that it deals with the credentials of users. And the credentials can be in a smart card. The credentials can be in a certificate which you put somewhere or through keys. And what they're doing is to have a reusable way of intermingling those credentials so that you could have multiple vendors and they can coexist. And you could use it in ways which allow you to do, let's say, physical access. So you could take your PIV card, which you have, and you could basically use that to gain access to a building. You could take the same PIV card, and now you could have logical access to the networks. You could have access to your computers, and through that, through remote servers, when you do authentications or when you sign some things. And generally, even though it's pushed by the US federal government, it's used by other agencies as well. So essentially all the other agencies which work with the US federal government, like the first responders, the local and state offices, the contractors that US government has, and more recently they have been adopted by the private industry as well. So the user base is growing, and the fact that they are interoperable makes it a really nice credential to have. The question now is that, well, how do we use these? Now, in the past, since the primary mode of access for people have been their PCs, these credentials have been used with those PCs. So you would have that in a smart card, like honestly what we have in Gemalto, that we have this corporate badge. So similarly, you could have a PIV credential, which is on this card, and the way you would use that is to essentially insert that into your computer, and now you would have logical access. Now, the same thing could be done with buildings. Through some remote sensors, you could basically just tap it, and now you gain access. The question now is that, well, is this the world that we are living in right now? And the answer is no. I mean, as we've seen throughout this conference, that the world of security and the world of doing business is evolving. Instead of using our PCs and our laptops, what corporations are doing more and more is to essentially leverage the mobile devices that people have, whether these are issued by the enterprises themselves or whether these are bring your own device concept where people use their private devices and then bring them to work. And now, just like they are using those in their personal lives, they want to use those in their enterprise lives as well. So here we have this IT department which is focused on adding security to the PCs by using credentials like PIV, and now we have people who are using their mobile devices. And the question is that can those security principles be transferred over to the mobile world? And that's what this talk is about. Now, one way to do that, of course, could be something like this. You bring in your mobile device, I take out my phone, and then I take out a smart card reader, and then I connect that to the phone, and then I carry both with me wherever I go. Is it convenient? Absolutely not. So what can we do about it? Now, another thing which has come out is that the concept which is derived credentials is at the heart of this. So instead of carrying my card with me all the time, I can take the credentials which are in this card, derive them, so that's why they're called derived credentials, and then put them in other devices, such as mobile. Now, the term derived credential was coined by NIST when they were looking at these concepts. And the whole idea was to take your security credentials and then move them to other devices. Now, based upon this, what we'll do is that we'll go through various stages of explaining this. So we'll start with the introduction to PIV as well as to the derived credentials to see how the two match, what the correlation is between them, how do you provision them on various devices. We'll talk about some examples of mobile applications which can use those derived credentials. Some best practices on how to manage them. So using them from the user's point of view, managing them from the IT administrator's point of view, especially when you talk about provisioning of those credentials as they move from your PIV card to a device that you own. We'll then go through some user experiences, and in that we were thinking of giving a live demo, but because of some logistics, we're not going to do that, but we'll do the next best thing, which is show you a video of the demo, which will show that from the user's point of view, how is it that we are getting both security and usability. And in the end, we'll go through some challenges and conclude. So before, so without further ado, I'll pass over to Benoit, who will essentially lead us through the presentation.
Okay, thanks, Asad. So first we'll start by a little history about PIV. So PIV stands for Personal Identity Verification. I will mention it a lot. So it was initiated in 2004. It was a security presidential directive that was stating the requirements for common and government-wide identification system. Because prior to that, each government agency would have their own way of issuing identity and verifying identity. So basically that was a way to enhance security, to increase government efficiency as well, and also reduce identity fraud by having a common set of standards for all agencies. So from that directive, the NIST Institute issued a standard, FIPS 201, and this standard is today used in the US federal government to provide interoperable credentials, so cards, keys, certificates. It's also provide a common and secure way to authenticate for access to buildings as well as networks, and all that with a consistent issuing process. So basically the vetting and the verification of the user's identity for issuing those credentials are well defined through this standard. So now, in the more, let's say, recent time, the incoming, let's say, the arrival of mobile computing and mobile devices in particular has led to change and update these standards in order to include the support for mobile device and the use of PIV credential in those mobile devices. So that's what they call the derived credentials. Basically, a set of credentials that are issued from an initial PIV credentials. So now let's go a little bit more into details of what is exactly this PIV and what is this standard. So the PIV standard is a set of components. So there are some definition of policies and procedure in order to manage, issue, and define what are the life cycles of the different credentials. What are the process for identity proofing, for verifying user before issuing their credentials. It defines also the use for physical access, like for example to enter buildings. It defines how to use and to store biometric information, like facial information or like fingerprints as well. It defines how to create, to store, and to manage a personal identification number, a PIN, which is used to secure and to protect the access to the credentials. So for application or for being able to use some of those credentials, the user, the end user, is prone to is asked to enter his PIN. And this PIN is defined and set up on the token or the device itself, and we never link it. Then there is a set of credentials for authentication, digital signature, and encryption. And it also defines the physical feature of the cards in order to prevent it from being counterfeited, so like some holograms or some display information. So that's for the PIV part. Now, moving on to the derived credentials. So from this initial set of credentials that has been issued, that can be used in corporate or government, for example, what do we do with mobile? So basically, what derived credentials define, and the update of the standard, is a way from this original set of credentials to issue a new, or for some credentials will be a copy of these credentials, into a mobile that will be stored in a secure element, for example, and we will see later in more details what kind of storage can be used for that. It also defines what are the credential lifecycle, and in particular the fact that if you're terminating your initial PIV credentials, that should also lead to the termination of all your derived credentials as well. It is also defined where those credentials are stored, and based where they are stored, if it's in a software or hardware components, you may be able to have different level of security, and what is defined also as level of assurance. Now let's go into a little bit more detail about what may be useful for the end user and mobile application, and what we will see later on in different types of mobile application. The certificate and the credentials that are going to be used and that we will use for our mobile application. So we have different set of credentials for encryption, authentication, signature. So in a derived credentials, the encryption certificate will remain the same, because regardless if you are on your laptop or if you are on your mobile, when you receive an encrypted email, you need to be able to decrypt it in the same manner, and people won't know if you're going to read it from your laptop or from any other device. So that one will be, let's say, common for both. And then for authentication signature, those two certificates and credentials are basically specific to each of the device or each of the secure token that you're going to be using. You will have a different signature, and we'll see a little bit further how is that. So first, let's go back to the encryption certificate. So this certificate will be shared, and this let's say credential will be shared between the mobile, let's say, derived credentials and the initial credential. It could be, for example, retrieved from an escrow, or it's also a certificate, or let's say a credential that can be exported from the initial PIV card. Now, for the second set of credentials, let's say they are unique credentials, and the reason is that those are issued in the following way. There is on the card of the mobile secure element, there is an onboard key generation, or public and private key, that is then used to sign a certificate request, a CSR, that is sent to a certificate authority. And then the certificate is issued based on those information, but the private key never leaves the token and or secure element, and those are not exportable. So when you will sign an email, let's say, from your laptop with your badge, it will be a different signature than when you sign with your mobile, because it's two different devices. And the last point regarding derived credential and let's say the data and the objects that are stored in the PIV credentials. So those data and object structure is similar between derived credentials and initial PIV. So they are both the same. The link between the initial PIV credential that were issued with a badge and the derived credential is maintained in the backend. There are different ways to do that, and NIST does not specify in particular which one to use. There could be also a way to link them together by adding in the derived credential some information related to the initial credential, like for example the hash of a certificate or something like that, to maintain the link within the derived credential itself, in addition to the link maintained by the backend. Okay, so enough talking about all those standards and information, and then now let's talk about mobile application, what we are using, and how can we make use of those credentials that are in the mobile now. So in corporate world, in let's say traditional and let's say most commonly used applications are secure email, obviously, VPN client, because usually when you are outside of your corporate network, you would be required to log in using a VPN, and out-of-band authentication, for example, to log on to some corporate website where the user may have some, for example, single sign-on technology, so he doesn't have to remember 50 different login names and passwords. So we're going to see the flow for the end user for those different applications, and then a little bit later on, Assad will present you the videos of those real applications as we made them. So first, the secure email. So let's say I'm John, I'm at the office, and I'm going to send an email to Jen, who is traveling out of the office. She's on a business trip. She's going to the LASCON conference. So I'm going to send her an email. I will insert my badge to encrypt the email and sign it. Jane will receive a notification on her phone, say, oh, you got a new email. See, the email is encrypted, so when she tries to open it, she will be prompted at that point to enter her PIN to unlock the access to the derived credentials in order to be able to decrypt this email. So then she'll be able to see the decrypted email, and she will be able also to verify that the signature of this email is valid, and it's a valid email coming from John. Now continuing for the second part, so we call it the outer-bound authentication. So now let's say Jen is back at home and she needs to do her expense report. So she's going to log on to a corporate website. Let's say she's using her tablet, but in her tablet there is no smart card reader, there may be nothing to plug in there. So she will enter her user ID, but that website requires PIV authentication or PIV credential to authenticate. So in order to do that, she will select an option that will be use mobile derived credentials, or use my mobile PIV, let's say. So once she enters information on the tablet on the website, then she will get on her mobile phone a notification saying you have an authentication request from myoffice.com. Do you want to authenticate? Yes, no. And she will then be prompted to enter her PIN code to unlock same way the access to her PIV credentials in order to establish mutual authentication with the backend and verify that she's authenticated there. Once this is done, on her tablet, she will then be logged in automatically to access her information. And now the next one, which is the VPN, Virtual Private Network. So this is, let's say, in a very similar way. So the user opens on his phone his client VPN application. He will be requested to enter the PIN in order to unlock the access to derived credential the same way. And then there will be a VPN establishment with a corporate network, and he'll be able to access his corporate network. There. So that's for, let's say, the main three applications, and we will see a video for two of them a little bit after. Now, we've talked about the credentials, we talk about how to use them. Let's see how do we bring those credentials onto the mobile. So the first thing that is specified and for derived credential is that it is based, the issuance of those derived credential is based on the verification and the valid initial PIV credential. So first, let's imagine the user will go to a portal for asking for derived credential to his mobile, and there he will have to authenticate using his badge. He may have to also enter some fingerprints or other types of biometrics recognition. Then from there, the data for that user will be retrieved. So it could be, for example, like the encryption certificate could be retrieved from a backend server. There may be some other also interactions that will be done in order to download onto the secure element in mobile phones some PIV applications that may be needed or some specific containers to be created prior to downloading those credentials. Then on the card, on the secure element, we'll have an onboard key generation for the certificates that are specific, like authentication or the authentication signature certificates. Then, as we said, we've seen earlier, we have a certificate request that will be issued to a certification authority based on those new set of key, and it will be loaded onto the secure element. So that's kind of an example for loading now. Where could be loaded all those derived credentials? So there's a lot of different places where it could be loaded. So let's start by the bottom part. So we have a UICC, which is also known as most of you probably as a SIM card. It's basically you have that in all your phones. It is used by a telecom operator, and it is used to store the credential for the end user in order to authenticate to the network for the telecom operators. Now, next to that, we have eUICC. It's an embedded UICC, so basically, it's just a different form factor of the same UICC. The difference is it is soldered onto the phone. We have also embedded secure element, or ESE. So those are basically secure storage, secure chips that are inside the phone. They are inserted during the manufacturing process of the phone, and they are used for secure storage inside the phone. There's also a possibility to use some secure micro SD. So basically, it's like the secure version of a micro SD memory card that you can see, but that slot may not be available on all phones. Could be also done through some, let's say, external connector, like a USB or micro USB connector in order to store some secure device outside. But then here we get back to is the end user going to be that great? Probably not. If we start to have to carry some external components to put on the phone. And finally, in the operating system, so today the operating system of the phones, there are some capabilities to store some certificate and to have some types of secure storage. Usually, they are software based, so they won't allow, for example, the same level of security or access than hardware token. Now that we've seen where we can store them, let's look at a couple of examples of protocols and way to secure the loading of those credentials onto the secure element. So let's say for the transport mechanism, it can be based on HTTPS or OTA. OTA stands for over the air. That's a standard protocol for remote communication to SIM cards for telecom operators. And it is used, for example, to transport the text SMS that you're exchanging on your mobiles. And this OTA protocol defines a security layer on top of the transport mechanisms for SMS, for text. And this security layer defines all the different encryption, signature of the message, integrity checks, anti-replay, and so on. So that's for the two, let's say, transport mechanisms that can be used. Now, in order to secure end-to-end from an applicative standpoint, so from the provisioning system all the way to the PIV containers or PIV applications that will reside on the phone, There are some other protocols defined by global platform that can be used for secure messaging, so the SCP02 or 03, which stands for Secure Channel Protocol, and one of them, the 02, is based on a triple DES, the other one being based on AES, can be used on top of those transport mechanisms to secure really end-to-end the credentials. Okay, now we kind of define all this. It's a nice talk, but let's see in reality what it looks like. So Assad is going to show you and explain you a video of the whole thing.
So we'll go through two videos. The first one will show the use case of having a secure email, which is sent from one user to the other. And the user that sends the email, that's John. So he'll send an email to Jane, who has to access the email from the mobile phone. So there, the credentials which are used to send the email are the PIV credentials. The credentials which are used to read the email are the derived credentials which have been loaded onto the mobile, as Benoit explained. So let's start. So essentially what we show over here on the right-hand side is essentially your the phone, which we actually show over here using my mobile application, which essentially takes an image of your phone which is connected and then shows that on the PC. And on the left-hand side, we have a PC client. So what John will do is that he'll open up the email client, basically type a confidential email to Jane, and the email would be both signed and encrypted. So essentially when it is encrypted, it will use the public key of Jane, the recipient. And that public key is of course retrieved through the certificate which is already there. And when it is encrypted, when it is signed, it will use the private key of John. Now in order to use the private key, John would essentially have to insert the PIV card, because that's what the key is on. And the key is protected by a PIN. So you'll notice that when we click send, you'll see a pop-up which will indicate to John, please enter your PIN. And that's the PIN to the PIV card which he's using. Once the PIN is entered, the private key will be unlocked. It will be used to sign the email, and then the email, which is both signed and encrypted, will be sent over. Now, once it is sent, we'll notice what happens on the right-hand side, which is the mobile application. So Jane will basically receive that email, but nothing can be done with that email unless you decrypt it first. In order to decrypt it, Jane will need to use the private key from the credential which has been loaded onto the phone. And then again, we'll see the same thing happening, that on the PC side, the PIN was entered so that it could be signed. On the mobile side, the PIN has to be entered so that it can be decrypted. And we'll see that the user experience is that on both the sides, you are entering one PIN. So essentially, behind the scenes, there's a lot of cryptography happening, but from the end user's point of view, it's all seamless. You insert the card on the PC side, enter the PIN. On the mobile side, you basically receive the email, you say, I want to read it. Well, the first thing you have to do is to enter your security PIN. You enter that, which is then used to decrypt. And you can actually see that the seamless flow of secure email. Now, from the user's point of view, it is no different than reading any other email which is not encrypted. Because when we receive the email on the mobile, we basically take out the mobile, here's an email, we tap on it, and then we read the email. So the only additional step is the 4-digit PIN which has to be entered. So let's go over to the second video, which is talking about out-of-band authentication. So we're all familiar with what happens in the online world when we go to a web portal. We have to authenticate. So the question is that what is the credential that we are using to authenticate to that portal? The easiest one that most websites implement is the username and password. But we all know that it's convenient to implement, but as easy to forge as well. Because once your email is out, or once your password is out, then anybody can impersonate you. So the question is that can we do some sort of an additional authentication? So basically now we're bringing in the two-factor authentication. What you know, which is your password, and what you have, which could be a device. Now, there are various ways of doing that. One option could be that, well, the website could essentially send a message to your phone where you pick up that message and then you essentially just relay that message back to the portal or back to the page, and now you have this out-of-band link. What we are demonstrating over here is much more secure than that because it's using the derived credentials which have been loaded onto your handset. So what we'll show here is that on the left-hand side we have my e-services page that the user is going to. So that's a service provider that the user wants to log into. Now instead of using the username and password, we'll see that it happens in a different way. So let's start this. So as we take, the user clicks login and then they say they want to log in. And now from the identity provider side, there are various methods that you could pick. And what the user does is that they say, okay, I want to pick my mobile phone as the device that I want to log through. Now, once it is done, notice that all that they're entering is their user ID. Now back on the server, that user ID is already tied to a phone number because the user has registered that device on the portal. With that phone number is picked, and then a message is sent to that phone number. Now that message has a challenge which has to be signed by the key which is on the device. Now at the same time, to make sure that the message is the same, there are two numbers which are displayed. There's one number which is displayed on the web page which says that's the authentication code, and then the same authentication code is displayed on the handset. Now this is not the same code which is signed, but it's just for visual correlation that yes, you are logging on to the same page that you had requested access to. And once the user says okay, then the additional second challenge which comes with this request is signed with the key which is on the phone, sent back to the server, and then the web page which is waiting for that response to come in would notice that yes, the user has been authenticated correctly with the right private key which was tied to that phone number and in correlation tied to that credential which was on that phone. Now the user logs in. Now in terms of the usability, we see that it's as simple as logging in with the username and password. But behind the scenes what's happening is a lot more secure. Now when I look at these scenarios, I'm always reminded by something that my math professor when I was in high school long time ago told me that, well, Asad, you are over here and you're working towards an exam in mathematics which you have to take, and then the requirements for that are over here. So you're over here, those requirements are over here. Those requirements will not come to you. You have to get to those requirements. So the standards will not be lowered for you. You have to reach out and get to that point. So when we talk about usability and how users view the applications and work with those applications, the same analogy applies. The users have a different mindset of what is usable. And we as security engineers and security professionals may have a different mindset. Now, they will not adapt to our mindset. We have to adapt to theirs. And what we see over here is a way of making things usable and hiding all the complexity and the cryptography behind. Now, is it easy? Perhaps not, because there are still a lot of challenges and a lot of things that we have to do, and we'll touch on some of them right now. So,
okay, so talking about challenges, so there's different challenges in this overall ecosystem. So let's start on the mobile side. So first on the mobile side, challenges just from the mobile itself. How can I access a specific secure element from the operating system? Does the operating system allow me to access to secure elements? So we know that today for some Android phone it is the case. It may not be the case for all operating system today. And if not, do I have some type of middleware then that the user may have to install that needs to be integrated in the mobile application in order to allow the access to those secure elements or those storage. Because today, operating system may provide access to credentials that are stored in their operating system storage or some sort of storage, but accessing to some, let's say, external storage or more maybe secure storage may not be in place today in those operating system. Same for mobile application. Mobile application may need to be modified in order to talk to a specific middleware that will access to a secure element if it's not done at the operating system level. Also, we have, say, the usual challenge of any computing device regarding to virus, malware, and all this nice software running in there. Now, going down to a secure element itself. So that's where we are storing those derived credentials that are used for the different applications that we've seen. So in there are some other changes that are who owns this secure element. It could be owned, maybe if it's an embedded secure element by the phone manufacturer. It could be owned by the telecom operator, or could it be like a trusted third party as well? So there are different question and challenge. Doesn't mean that some of those are not resolved today. I mean, today there are some applications that are deployed by telecom operator, for example, for mobile payment that allow, let's say, service providers to access secure element through some trusted third party or through the telecom operator themselves. So that's, let's say, also related to changes regarding provisioning, because then with the ownership of a secure element comes also the ownership of the keys that will allow the access to the secure element. After, there are some, let's say, standards, like in global platforms, that will specify that you can create some specific security domain where you could have separate, let's say, equivalent of tenants that will be inside the secure element, completely separated and compartmented from there. Also, another challenge is how do you restrict mobile application from accessing your credential? So today there are some access control functionalities that are embedded in operating system of the phones, and that can be done in addition to, let's say, the usual protection provided by the PIV implementation itself regarding to the PIN, and as well as some other mechanisms defined by the standard. Now, obviously, for deployment in, let's say, in corporation or even in government agency, there will be some changes that will be required in terms of policies, as well as the management of a certificate lifecycle, because now we have another set of credentials in addition to the initial credential for the same user. And we need to make sure, for example, that if a user, basically, if some credentials are terminated, that the derived credentials associated are also terminated with it. And one more thing on that also is due to the mobile device, it's bringing a new model compared to the traditional, let's say, IT ecosystem where IT in corporate world may have control over the infrastructure, maybe have control of, let's say, software that are running antivirus, backups, VPN infrastructure, and so on. In mobile world, it's a very different scheme, because everybody brings their own device. They change device quite often, so it's out of control. So for that brings some additional challenge where some solutions like mobile device management can partly answer to some of this, or some other way where you can have some containers or compartmentalization between, let's say, professional use and personal use, because in fact your mobile that you use to check your corporate email, maybe the next minute you'll give it to your kids so they can play a game on it. So we are mixing professional and personal life and data in there. So that's another of those challenges. So the paradox of the dilemma between mobile versus laptop. So in corporation, as we said earlier, there is a history and let's say a well-known threat model. IT has the control of, let's say, the environment, whereas the arrival of mobile and bring your own device is kind of breaking this model and has led maybe to relax the rules for mobile for the sake of user convenience. Let's say today, maybe I go home and I want to check my emails on my laptop. I would have to insert my badge, connect through VPN to my server, whereas just take my phone maybe and then just check my emails. That's so much more convenient, but we are losing maybe a little aspect of the security there. And that's probably a good example where convenience trumps security. And in this presentation, we hope that the derived credential examples that we show is basically how we can achieve both security and convenience using a personal device. I think.
Any questions? Stop or anyone? I guess we're done then. Thank you.